I am Nicola Vella, and I am a colleague and friend of Phineas, which we both work at OPSEC, at Security Researcher, and we are both CTF players. So let me share the slides. Okay. Okay. Can you see the slides? Okay. Thank you. So this lesson is an introduction to software binary exploitation, and I'll basically explain what it is and like why it's interesting. And we'll see some examples of bugs in C, like memory and safety bugs, and how to exploit them. So, what is it? Uh, it's commonly referred as pawning. Like binary exploitation, it's not like used a lot. You will commonly see like pawning on CTFs. And let's say it's like the art of turning behavior of a program into your control. Okay, maybe that's too theoretical. So let's take a real example. Let's spawn sudo. So the normal behavior of sudo is to execute other programs with super user privileges if the requesting user is allowed. So you do like sudo ls of like slash something that you cannot access, and sudo asks you about a password. You insert the password, and sudo is like, okay, that's the real password, so I'm gonna treat you like a super user. If you enter the wrong password, like sudo is gonna fail. Mm, while the pawn behavior of sudo is like you can execute other programs with super user privileges without the real password. Uh, why like would you like to do binary exploitation? Like why would you learn binary exploitation? Firstly, it's an interesting way to understand low-level concepts, such as like what happens when you make a syscall, what assembly corresponds to some C source code, and there are a lot of like some real-world use cases, uh, more fishy and less fishy. Like you can protect your software by attacking it. In fact, a lot of the big corporations usually have like internal red teaming uh, teams and internal pen testing teams. For example, Google, Apple, stuff like that. Always have like some internal team which continuously try to break their software to actually protect it, like find bugs to fix them and put in place some mitigations. Uh, Another like fishy usage of binary exploitation is the intelligence operations. Like you want to access the phone of, I don't know, some terrorist, so you gotta have like some way to do it. And nowadays, the way to do it is exploit software vulnerabilities on like your phone, your browser. Um, Another like for fun uh, way of mm, use by exploitation is like game cheating. I don't know if you have seen the recent viral Apex Legends videos about like a pro player playing a pro game and getting hacked like pretty crazy. And that's you can do it if you learn by exploitation. So please learn it. Uh, How is possible to divert like how it's possible to make sudo do stuff without a password. Mostly because languages like C and C++, developers have like direct control over memory management, and like this can lead to bad vulnerabilities such as buffer flows, user-free errors, and other memory-related issues. And but like why memory-related mistakes are uh, so powerful? We are gonna like understand it uh, with like some examples. So first, let's understand what kind of bugs we commonly find in C programs, and then we will try to understand why those bugs are usually like super powerful from an attacker's perspective. So, for example, let's take a common strings ending function in C that if you like ever programmed in C, you probably used it. So, for example, let's take string copy. String copy has no way of verifying that the destination buffer of um, what of like where you are copying to string is large enough to store the source buffer. So that's a pretty big futka because what happens if you pass a large string as a source operand, which cannot store in destination because destination is a small buffer? Well, it, a lot of stuffs can happen, and we'll take a look at like what can happen. Technically, in C, it's like undefined behavior, and the manual says that uh, if you are copying a string inside a buffer which cannot hold the string, then it's undefined behavior. And how it's defined the undefined behavior for like C compilers for if works. Basically, it means that anything can happen. Well, that's a like pretty theoretical take. So in this lesson, we are gonna take a look at like what actually happens under the hood when you supply a large string that cannot be held by a buffer, by the destination buffer. So, for example, let's take this function as an example. Say hello, which takes an input string, and it copies the string to a local allocated buffer, and then just prints it. So we have like one big precondition. Your name must be a valid pointer, so it must not be a null pointer, and it it needs to point to a C string of length which is less than 10. The behavior is that this function prints a hello followed by the passed-in string when only when the previous precondition holds true. Otherwise, it might as well like start mining cryptocurrencies for what you know. Okay, that's still pretty theoretical. Let's see how we can exploit it. What we have seen previously, is a common example of stack buffer flow. Mm, in particular, we have the powerful primitive of overwriting some memory adjacent to a stack allocated buffer. Um, like buffer flow in general are pretty powerful in C, but only like when you can overwrite something meaningful. And luckily in the stack of C programs, the CPU stores data that is used to control the control flow of the program. Let's take a look. So that's the stock content of the function of the CLO function. We have the local variables, which is only buff with length 10. Oops. And then we have the control flow key data, which is the previous PC and previous VP. What is previous PC? It basically points to the function that called the current one. So when the current function finishes its execution and returns, the CPU knows what to execute, basically. Let's try to run the program. So in this example program, when the main function calls the say-hello function, the CPU stores in the stack the address of the instruction after say-hello. So in this case, after say-hello is executed, is called, the CPU is gonna store the address of this instruction here. So return 0. Let's actually take a look at like what's in memory uh, of the say-hello function. So if we pass your name equals to like 10 times haze, then uh, we can see that in the stock there are like 10 haze, which is every haze 0x41. So there are 10 haze and then some random stuffs. What is these random stuffs? That's actually the previous BP and the previous PC. In fact, if we try to send more than 10 A's, for example, 32 A's, then something pretty fun is going to happen. So what, what is happening here is basically we overwrote those control flow key data we were talking about before. So we overwrote the previous BP and the previous PC. That means that we took control of the program because now the program counter is pointing to an address we supply. So, what are the implications of these kind of bugs? Basically, we can make the program execute whatever code that we want, and if the program contains some interesting code, we can jump to it. Otherwise, we can try to inject some interesting code and try to jump to that interesting code that we injected. And moreover, this is like uh, the reason we say that memory corruption vulnerabilities are pretty powerful, you can see, is that like this technique can be applied to any C program vulnerable to stack overflows. So it can be the Linux kernel, your browser, I don't know, your WhatsApp, Facebook, basically any application which is embedding C code is exposed to this kind of bugs, which can basically make the control flow diverted to everything the attackers want. Let's continue and see some common C bugs. Uh, like now that you are like we have seen why memory and safety bugs are so powerful. So let's see like some other ways stuff can go wrong. Basically, every API in the C standard library is inherently unsafe because it was like all those APIs were developed like a lot of time, a lot of years ago, where like when like applications were not exposed to the internet. So like the user input was just like uh, people inserting some numbers in a calculator to do some calculations, for example, or stuff like that. It was never that um, mm, like there wasn't like some attacker controlled input. It was always like just user controlled input. So at that time, it was fine to develop APIs like that. Um, like this example, why is this API pretty bad? Because uh, it takes a destination buffer, which is S. It takes a format string and some parameters, and then tries to print that uh, format string inside the destination buffer. It has no way to check that destination buffer as the as like enough sites to hold all the data. So that's the same bug we've seen previously with the string copy. Another bad API, a bit better but still bad, is the mem copy, which copies n bytes from the source buffer to the destination buffer. Again, this has no way to check that the destination buffer holds enough space to hold all the n bytes. It has no way to check that the source buffer has enough bytes to read n bytes. And so there are a lot of ways this can go wrong. And we are gonna see like a real world example. So just to test that that's not like something that can never happen. Another common C bugs is the gets function. Nowadays, if you try to like compile this a program which is using gets, the compiler is gonna yell at you. So um, that's like something good about C, but still you can still use it. And what it does is like getting a string from the keyboard and just placing it in the s variable. Again, this has no way to check that the s destination buffer has enough space to hold everything. So stuffs can go wrong, like went wrong with the string copy. I can continue like that and show like some other manual page, like printing, like and saying like how why every function in C is bad. But I'm gonna like stop here and try to give you like some tip and tricks to find vulnerabilities. So like definitely number one is every time you like if you're reading a program and you don't know what some function from the standard library does, try to do yourself like man function name, and Emmanuel is gonna tell you like what's wrong about this function and what are all the preconditions. So like example, before we analyzed this function by finding the precondition. The condition here was your name is a valid pointer which points to a tree of length minus 10. Um, the preconditions of standard libraries functions are in the manual. So, for example, the precondition of memcopy was that the destination buffer has enough space to hold source buffer. and the I don't know, the precondition of gets is the same, that the destination buffer has enough space to hold the input from the keyboard, etc. So every time you're looking at some C code, what I recommend you is try to find the preconditions under which that function well behaves. Moreover, if like there are some functions with lots of preconditions which accept user-controlled input, try to break those preconditions. What does it mean, like breaking a precondition? Again, let's return to the mm, say hello function. In this case, breaking the precondition here is passing a string that which have a length more with more than like 10 letters inside. And another like small trick to find null is like grepping for unsafe functions like sprintf, memcopy, gets, copy, and struct. And basically, all the functions in the library of it. So I'm gonna make a pause now and to ask like if you have some question, and then I'm gonna like do a small demo. Do we use like this document? Okay. Okay, if there are no questions, then let's do some more example. Like I said before, the grab and trick. For example, here I'm gonna show you like some real code base, which is from the Dolphin emulator, which is Wii emulator for zoom in. It's a Wii emulator written in C++, and we are gonna um, I'm gonna show you like how powerful it is to just grep for unsafe functions. So mm, that's literally like C++ code base. Um, I don't know if you have played uh, for like Wii games for the in the PC, but that's the way you would do it. Mm. And like I'm gonna try to apply the mem copy tip and tip. So let's search for mem copy. Uh, there are 400 results. Um, some of these mem copy are like with fixed size, so you can tell that okay, it's kind of okay to do that, and a lot of them are from crypto libraries. So you can ignore it. control 2 more seconds. Shit. Is it okay now? Okay. So, okay, let's try to analyze this function. Uh, it takes a destination address, a length, a source address, and try to do this check. So, if the destination address is inbound, then do do this mem copy from destination address with this wide length. Um, First thing you can notice is that this check is not using the length parameter. So that's null. But let's try to understand what this address inbound function does to understand like precondition of this function. So precondition uh, stop ChatGPT. So preconditions uh, destination address is an address inbounds. We are gonna understand what this function does, and memcard destination address plus is uh, can hold at least length bytes. So this precondition is something that the program itself is giving it to you. This other precondition is a precondition that I can infer from the code. So because if this is not true, then the mem copy is doing undefined behavior stuff, which means that it is a buffer flow, and it means that it can like mine cryptocurrencies instead of playing the Wii games. Well, let's check what this function is doing. So, okay, which means that the start address is less or equal than memory card size minus one. Okay, what card data is a buffer of what length? Okay, card data is a buffer of length and memory card size. Uh, so let's try to verify this one. Hmm. I don't know. Those are preconditions. By facts. So card data as length memory card size. Uh, this so this means that like These stuffs can point to the last byte of the allocated uh, memory, and so when you try to do mem copy, like from the last address, and with a length of like anything, because this is not restricted, this is gonna cause a buffer flow. Uh, do you have any question about that part, like about getting the preconditions of like this function? I, how, how we use this with a makefile server? Sorry, I don't understand the question. Like, what is this? What were you referring as this? Could you clarify a bit?
I asked this question before starting, so uh, that's possible.
Okay, we can go back to, yeah, like in what slide?
I was curious if you can use this method to
Sorry,
get access to maybe a server or maybe have endpoint.
sorry, I cannot hear it like, pretty well. You type it out in the document. Okay. Okay. So if I like everything here was here, then we can go on. The point I was thinking is, is like one of the like best way to like find vulnerabilities is probably like try to um, find like say code base um, functions that are like hard to use. So in this example, this function is hard to use because crawler needs to be sure that like this length um, is constrained to like by the destination address. So like if the destination address is like the last thing in the memory card the data, then the length can only be like one. Um, other like examples uh, um, of like uh, unsafe functions like that are functions which like call string copy with user input, call staccato user input, or function like that. So yeah, um, okay, we can go back to your question if you want. Uh, Here's this map to gain access on an API endpoint. For example, the server is running .NET. So, well, uh, so this methodology. applies to every language, but like every language has its own unsafe stuffs. So on C and C++, there are a lot of unsafe stuffs because once you have like one memory mistake, then you can possibly take over the execution of the whole program. So like if you take um, two really different programs like browser and the game, then you might have like the same bug on the browser and on the game. Like both might have a stack buffer flow, the user controlled input, and the way to exploit it is the same. Just because it's written in memory unsafe language, and it's possible to like make memory mistakes. On the other hand, uh, .NET is not like memory unsafe, so you cannot like really make um, memory mistake which can be exploited with what we've seen. So, but there are a lot of like mistakes you can make on .NET servers, uh, which are like different from memory corruptions, but like mm, probably powerful too. Uh, I don't know. For example, a dumb bug on like a common dumb bug on .NET is probably object visualizations. I'm not like quite sure because I don't really like do web stuffs. So, so yeah, I'm gonna put it like here. For example, like a common way to get RC on .NET servers, is like if you implement like badly the deserialization of objects, this can this can like this kind of exploitable like memory corruption in C probably. Okay. Uh, wasn't something like not clear, and you want me like to repeat it, or do you have any other questions? Okay. Um, then okay, we can like end the lesson here, and let me know if you have any more questions. I can reply you like even after, and I'll send you the slides. Okay. Bye bye everyone. Mm, hopefully you are gonna like learn more by exploitation and like find some really cool buoy, get some RCs. Bye bye.